The other thing that I want to talk about is the building monitoring program and the vertical survey and measurement system. Obviously, when you think about these very tall tower, the surveyor has to put the building in position all the time. But obviously, Dubai is a little bit of a windy day, and every time he does a survey, the building is moving this way on him. Okay, and you're going at 800 meter and above, maybe 700 meter and above. I don't know, but at the end of the day, he needs to know where the center of the building is, where to build it to at that instant of time. When the building is very short, there's no problem. There's very little movement. You can control that with the optical survey. Because as you go up, what we end up doing is, and also the visibility become very low, and in order to transfer all of these points up to get the building located accurately is very difficult. So at the end of the day, what investigated the GPS system that used as a survey from the beginning of the construction. And the GPS system, it was an excellent one, because as the building moves, it's not a steel building, it's a concrete building. And all the data that we can measure in 1 or 2 hours, the average of that point tell us where the center of the building is. And practically we have to use, process the data, take it, measure it, locate exactly where the center is, and say, okay, this is where it is. And we have been extremely lucky that we have been building the tower, considering everything that you have seen so far, within less than a 25 millimeter tolerance. Okay, so essentially the formwork system and all the construction method that you use is extremely excellent. The formwork system, the auto climbing form system is like measuring, is just doing a manufacturing thing, almost exactly like you're doing in a machinery. And essentially the GPS system consists of one fixed station on the site, and also 6 fixed points in order to measure things, and also rovers, which is at the top of the formwork climbing form system to locate where everything is. Essentially, it consists of one fixed base station, second movable base station, and 1 rover. And foundation, the other thing that we did in the monitoring is a foundation monitoring. We have located all monitoring locations for both survey to look at the settlement constantly, what's happening with the foundation system, horizontal monitoring of the building to measure what happened with it, because as you can see, a lot of setbacks. And the question, how is the building leaning with time? Also, we need to keep a track of what's happening with the building relative as we're building up. And also the vertical monitoring of the building relative to vertical shortening between the wings and the columns, and so on and so forth. So essentially, we're implementing a very extensive monitoring program in which we installed strain gauges at different locations. And that was very important, because not only we wanted to verify the initial concept, everything is working exactly the way we're expecting. And in other words, as I showed earlier slide, the load is going to come from the top and shift to the end. And what do you expect is an equal stress in every single element. And the question, are we getting that? So the building essentially is instrumented at all kind of strain gauges for the entire height and extensively. And also we have a weather station to measure wind speed, direction, temperature, humidity, and also communication control points. And these are the kind of instruments we used in the building, both weather stations, strain gauges, and for every level we have a data logger that speaks to a central data logger station at the bottom of the building to measure it. So practically what you see, these blue dots, is all the locations at every level that you see in the elevation where we instrumented and installed strain gauges, and also some weather stations. So this is level 22, level 36, all the way up. So what you see in this elevation here, at each of these levels, all of these columns have been instrumented and located. And practically we got a very excellent results, because you wonder, what is the concrete temperature? What's the heat of hydration? Is there a crack over there? Is there something? So in order to reduce anybody's mind, practically what you see here is the heat of hydration of the concrete. The temperature rises, and the microstrain is about 600. And then when the temperature goes down, the maximum temperature that you see in the concrete is about 50 degrees centigrade. And as it goes down, it gives us how many days it takes to come down. So essentially, we got all the essential things that we needed to do, correlate the mock-up, the actual building, to so we make sure everything is done in according to plan. This is level 22, the same thing. Level 22, level 36, as you can see, essentially we're getting similar behavior. One important thing also to look at is if we take a survey of all the points on the floor and look at how much displacement there is, essentially it's all uniform. Okay, which is there is no differential whatsoever.